All right, so this is the mathematical version. Notice we're not going to draw anything for this. I'm going to just use the numbers to predict the image type for each of the 17 and 18 here. You've got a object is placed along a principal axis, thin lens, and has a focal length of -15. So that's going to be F equals -15 centimeters. All right. And the distance from the object to the lens is 10 centimeters. So that's going to be DO is 10 centimeters. First one is calculate the distance to the image. So it wants DI there. So we're going to use the equation 1 over F equals 1 over DO or DI. It's addition, so you just add them together, plus 1 over DI. And then I'm going to plug in the things I know and solve for the one thing I don't know. So this will be 1 over -15. Now remember, -15 means it's a diverging lens. I mean, it says diverging lens there, but -15 means that negative focal point. So the light's going away, and we know we're going to get an imaginary image or virtual image. All right, 1 over 10, and that's going to be plus 1 over DI. So now I just need to solve it. So I'm just going to grab my calculator, and I'm going to put 1 over -15 minus, right? I'm going to bring the -10 over, minus 1 over 10, and I'm going to be left with 1 over DI equals 0.166 repeating. All right. Now, that's not the answer. The answer is going to be 1 over this. Actually, I think there's a negative there. Yeah, because 1/15th, -1/15th minus something else is going to be 1 over that. So negative this thing. So it's going to be negative this. It's not a very good negative. All right, and so I need to find the denominator here. So I need to take 1 over both of these. Remember, that calculator button is the X to the -1 button there you want to push. And when you push that, that will give you DI equals -6 centimeters. So that's an image distance that's negative. So I know that's going to be virtual. We'll do that in a second. Let's just leave that there. Calculate the magnification. All right, magnification can be done with height or distance. Since I only know things about the distance, though, I've got to do it with distance. Negative DI over DO. And so this will be negative, comma, or parentheses, -6 over distance to the object, 10. And that comes out to be positive 0.6. And so that is a magnification of less than 1, which is that value. And that's going to tell me that's smaller. All right. So this is where we get to what is the image type. Well, since we only know DI, let's just talk about that. Maybe we'll know the H's in the next one. If distance to the image, DI, if DI is positive, then I know it's a real image. If distance is negative, then I know it's a virtual image. Now, you're smart though, and so you know that real must be also inverted and virtual must be upright. So you can add those two together. And so then we jump down to what image type is formed. So we'll go through and look at that. So it is a virtual image. It's upright. And its magnification is positive, which confirms that it's upright. And it's less than 1. So it is smaller than it was. Right? So you can kind of put that together. But want to know that little thing right there. All right. Number 18. Now we're looking at an object 20 centimeters from the thin lens. Image distance, anything about the height. So we're not doing height here. That's okay. Calculate the focal length of it. All right, so focal length, 1 over F equals 1 over DI plus 1 over DO. Again, I may have done that backwards there, but it's plus, it doesn't matter. And plug our numbers in. So I get, let's see, 1 over F equals 1 over DI, 30 centimeters from the lens. So positive 30 right there, plus 1 over 20. And that is going to give me a decimal of, let me get that number. All right, 0.833, repeating. But again, I need to take that 1 over, so I need to use the x to the -1 button, and I'll get the focal length is 12. So that tells me it's a converging lens. We knew that already. So there's a focal length. Calculate the magnification. Well, magnification is going to be negative di over do. And so we'll have negative distance image, negative 30 over 20. And so we get negative 1.5 as my magnification. And so there's a couple things. There's negative, that tells me that it's inverted, but I also know the di there. So it's inverted, so therefore it must be real. And then the size is larger because that is greater than 1. All right, so those are the first two calculation ones. I'll put the next two on the next video.